Find the number of triangles whose vertices are vertices of a regular octagon. Octagon means a polygon having 8 sides. So we have to find the number of triangles whose vertices are vertices of a regular octagon, but none of whose side is a side of octagon. So this is one interesting problem. And here the important line is that there should not be any common side between the octagon and the triangle. Now see here, if I want to create triangle which do not have any side common with the side of octagon, so basically we have to select three vertices and the condition is that no two should be consecutive, right? For example, suppose if I select points like 1, 3 and then 5, so then we'll get a triangle which has no side common with the octagon. However, if you select any two consecutive vertices, for example, if you select 1, 2 and then 5, so then this side will be common between the triangle and the octagon, right? So there are different methods of solving this problem. One of the methods will be that first we'll count the total number of triangles and then we'll remove those triangles which have either one side common or two side common, right? Now, finding total number of triangle is not difficult. There are 8 points. All of them are non-collinear, right? No three of these points are collinear. So therefore, total number of triangles that you can create is 8C3. Now let us try finding how many triangles are there which have one side common with the octagon, right? First, I mean, there are three possibility. Either the triangle will have no side common, or it will have one side common, or it will have two sides common. So from the total number of triangle, if I remove those triangles which have either one side common or two side common, then we'll get those triangles which have no side in common. So if we talk about number of triangles having one side common, so for example, let us say if I select point 1, 2, and then the next point we select is this point 4, right? So then there is one side common between the triangle and the octagon, and that side is the side joining these two vertices 1 and 2. So if I need number of triangles having one side common, then we need to select two consecutive vertices, and the third vertex should not be consecutive, right? Now, in how many ways we can select two consecutive vertices? So either you can select 1, 2, or 2, 3, or 3, 4, and in this manner up to 8, 1. So these are the different ways in which you can select two consecutive vertices, right? So if n1 is the number of triangle having one side common, then n1 will be select any two consecutive side. For example, 1, 2, or 2, 3, or 3, 4, and so on. Once you have selected 1, 2, 3 and 8 you cannot select because then you will get three consecutive vertices and then you have two sides common, right? So 1, 2 already selected, and then 3 and 8, these two you cannot select. So now from the remaining four vertices, these four vertices in this example, if I have selected 1, 2, then 3 and 8 we cannot select because we need only one side common. So from these four vertices, select any one vertex. So 8 into 4C1. 8 is the number of ways of selecting two consecutive vertices, and then 4C1 is number of ways of selecting any one from these four vertices. So this will be 32. So total there are 32 triangles which will have one side in common. Now let us try to find how many triangles are there which will have two sides in common. Now this one you can very easily see that if I need two side in common, so then we have to select three consecutive vertices, right? For example, if we select the vertices 1, 2, 3, or if we select 2, 3, 4, then we'll get two sides in common. So now how many ways are there of selecting three consecutive vertices? So either you can select 1, 2, 3, or you can select 2, 3, 4, or 3, 4, 5, and so on to 8, 1, 2. Right, these are the different ways in which you can select three consecutive vertices. Now, clearly you can see that there are 8 different cases. So, number of triangles having two sides common, that will be 8. And now, our answer will be total number of triangles, this is 8C3, minus the number of triangles having one side in common, minus the number of triangles having two sides in common. 8C3 is 56, minus 40, that will be 16. So that should be the correct answer for this problem, right? So this was a problem where first we had to find total number of triangles, And then we had to remove those triangles which have either one side in common or two side in common. Number of triangles having one side in common, 32. Number of triangles having two sides in common, 8. And therefore, number of triangles having no side in common, 8c3 minus 32 minus 8, which is 16. And therefore, the correct answer for this problem is second option.